The subject of this tutorial is valve sizing for liquids. Navigation to the valve sizing page can be performed directly from the Welcome Screen page via the Start Quick Size Now button, as shown in the following demonstration. Navigation to the valve sizing page can also be accomplished by navigating to a specific customer, project, and valve lookup tag as shown. Once on the valve sizing page, the user can start the process of sizing the valve. There is required data for the proper and accurate sizing of any control valve. The minimum data required is, firstly, what is flowing through the valve. The user can select from the drop-down list either liquid, gas, or steam sizing. Standard is the default and is selected when a liquid is chosen from the drop-down library. The factory default is water. If the liquid is not in the library, then custom would be selected and additional information will be required. We will address that later in the video. Next, inlet and outlet piping diameters need to be selected. Another feature of the ValveSmart valve sizing application is that it automatically performs a correction of flow rate calculation, taking into consideration the resistance of installed fittings. Next, it is preferable to obtain the flow rates for the minimum, normal, and maximum process conditions, but at a very minimum for the normal or maximum process conditions. Additionally, other data that's required would be the inlet pressure to the valve and either the outlet pressure or pressure drop. If neither the outlet pressure nor the pressure drop is known, then assume the pressure drop is 25% of the inlet pressure. Note, however, that actual valve performance will depend on the actual process conditions and not on the assumed condition. Lastly, the required data to be able to size the control valve would be to obtain the temperature of the liquid at flowing conditions. The example used is going to be in a system with 2-inch Schedule 40 inlet and outlet pipe diameters. The flow rates for minimum, normal, and maximum process conditions are 100, 200, and 300 gallons per minute. You can change units by using the drop-down list and choosing the appropriate units. Next, enter inlet pressures in the appropriate columns. Again, you can change the units by using the drop-down list and choosing the appropriate units. Then enter the outlet pressures. Finally, enter the fluid temperatures for each condition. At this point, a preliminary calculation can be made by pressing the Calculate button to perform a simple CV calculation to determine which valve would be initially the best choice. In this case, we need a valve with a maximum CV of 67.082. The ValveSmart valve sizing application utilizes calculation algorithms, methods, and equations that are in accordance with industry-accepted ISA standards. ISA methods and equations are valid with the maximum liquid inlet velocity of 33 feet per second. The program calculated this maximum valve diameter in order to keep the velocity under 33 feet per second. At maximum flow, the minimum size valve we should select is 1.928 inches. To select a valve, go to the Valve Type drop-down list. In this example, we are going to select a V-ball. Next, select the series. In this case, OB-DM2500 is a flanged V-ball valve. Then, select the valve size. From the preliminary calculations, we should use a valve 2 inches or larger, so we will select a 2-inch valve. We will use the default ANSI 150 rated valve. Since V-ball valves are inherently equal percentage, that is the only choice in the trim type. Also, V-port is the only choice in the trim style. Looking at the drop-down list for rated CV, you can see there are 4 rated or maximum trim sizes available. Since we need a valve rated for over 67.082 CV, then we will select the 135.75 CV trim, which is a 60-degree V-ball. We will choose a 316 stainless steel body material. You can also enter the optional maximum design pressure and temperature that the valve will ever see. When you calculate or move to another field, the box will turn red and a warning note will appear in the Conditions and Notes text block. This will also appear on the results printout form. Now press the Calculate button and view the results. Best practice is to select an optimum valve so that the percent open at minimum flow is greater than 15 to 20%, normal flow rate at 55 to 65%, and maximum flow rate is less than 80 to 85% open. In this case, all conditions meet the optimum selection, with the normal flow rate being a little over the high side, but certainly acceptable. ValveSmart valve sizing application utilizes predictive analysis in accordance with ISA standards, including choke flow, incipient or the potential for cavitation, flashing, laminar or non-turbulent flow that would affect the performance issues or potentially create damage to the valve or downstream piping. The flow condition subcritical means there is turbulent flow or good control, and there are no adverse conditions predicted. After performing the calculation, the user can print the results by pressing the button with the printer icon. The results printout preview page should pop up. If not, check to make sure the browser is not blocking pop-ups. If so, disable the pop-up blocker for this website. To print, simply right-click and choose from one of your available printers or PDF writer, so save, to print the form which is in accordance to ISA standards. After performing the calculation, the user can view the selected valve performance curve and up to 4 entered process results. This can be done by clicking on the button with the chart icon as demonstrated. By moving the cursor over each point, the user can view which point, minimum, normal, maximum, other, and the percent open, percent CV for that operating point. The user can move the point of the cursor anywhere on the curve to view the percent open, percent CV at each selected point. Other valve details are shown at the right of the curve. You can print this curve by right-clicking and then press Print. There are other features of the program to reduce the potential for valve issues. We will demonstrate a few of these. Best practice is to select a valve no larger than the inlet and/or outlet pipe diameter. There is a pop-up warning to remind the user of this. The user is also warned if he or she selects a valve where the calculated CV exceeds the valve's rated or maximum CV, as the following demonstration shows. A final example is the application's predictive analysis to warn the user when process conditions may cause damage to the valve or downstream piping, in this example, cavitation. By changing the outlet pressure in the maximum flow conditions to 30 psig, flow conditions for that column changes from subcritical to cavitation. Incipient is when conditions are right for the onset of cavitation or cavitation with insufficient energy to cause damage. Increasing the outlet pressure in the maximum flow conditions to 40 psig, flow conditions for that column changes to incipient. Once the user is satisfied with the selected valve and results, the data can be saved for future reference by pressing the Save button. The procedure for sizing steam and gas are similar to liquid sizing. However, there are unique predictive analysis to these two compressible fluid media, such as OSHA limits on excessive noise and valve damage from high velocity. Therefore, separate tutorial videos are dedicated to those two flow media.